All right, everyone, it is now 3:30, so we can get started. Welcome back to another lecture for Comp 426, Modern Web Programming. This is lecture 16. So I hope you all had a great fall break. We're going to be continuing building up our tool set in terms of our backend for our applications. Okay. I'm going to get started here with some announcements. So the first main announcement, which you kind of alluded to on the Canvas post last night, is that the next assignment has been opened. This is A05. It's called Oriole. It will be due at the end of the month, in the end of October. And you will be implementing the full backend functionality for a social media app. So you will have a full working social media app by the end of the assignment. You will be able to have different feeds. You will be posting. Profiles can follow other profiles. You can like posts. They'll be signing in, which we'll be talking about today with authentication. And then finally, also uploading images and et cetera. You will also learn a very important technique for loading data called infinite scrolling. If you notice in an app like Twitter, you can just keep scrolling forever and data just continues to fill in. Same with Instagram, right? In A04 Pokedex, you use the different arrows for next and previous pages. But in this case, you're going to learn how you can just scroll and it will basically load infinitely. And so that is a very, very common data loading technique. And so we'll have the chance to explore that in this assignment. In addition, the UI has already been given to you, so you don't have to worry so much about worrying about the UI. You'll mainly be implementing kind of the backend functionality and interacting, for example, with the database, et cetera. Okay. I do recommend, as always, I always recommend this, but I will again this time to start this one early. It is a little bit of a larger assignment, not necessarily in the to-dos, but just there is a lot of code to make all this work because this is a full it's a much larger application than what you have had to work with in the past. To also help with introducing some of the new tools that are used in this assignment, there is a short pre-reading. This is just essentially part of the assignment grade. So it's not a separate reading grade. It's all 95 points out of 100 for the assignment are the actual assignment, and then 5 out of those 100 points are for this pre-reading. So this is going to be due this Friday just to make sure that you are kind of pacing yourself correctly and that you have taken a look at this before. There's only like 3 questions. And so all of this has been posted already to the website, so you should be able to access it there. Any questions? All right, perfect. Again, also, as I noted in the announcement, due to the AWS outage, a lot of different sites, including Canvas, I believe Gradescope as well, were down at some point yesterday. And so for that, we extended the reading again one more day. So you had, if you lost any time that you couldn't work on it because the websites were down, you now had the extra day. So that is due tonight now. And great work on that and great work on Pokedex. Already started to look at them. They're looking really good. So we're going to be working on grading that this week. All right. Now, again, I think because this is so relevant to what we have been talking about in class, I think this would be a good digression to take for a few minutes to kind of talk about what actually went wrong yesterday. As you know, many major sites, including Amazon, Canvas, the one you used, Venmo, Duolingo, I believe, which was kind of funny, I think Fortnite as well. All of these different applications went down for a very long time yesterday due to an outage with AWS, which stands for Amazon Web Services. And it is estimated, although it is not currently, they'll have to figure this out, is that there is a massive, massive economic impact of this. I believe also with different airlines, for example, Delta, United were also affected by this outage as well. And again, you all got an extra day on the reading because of it too. And so I would like to kind of talk a little bit about what actually went wrong here. And this relates really well to what we've been talking about actually. And you then can kind of see how the different things we've been talking about are related to even large-scale production systems like AWS. Okay. So in the past few lectures, we have been talking about this idea of these backend servers right here. So in our applications, this is where our next server functionality is living. That's where our APIs are run. And then we also have the data server, which is storing our database, right? Because our database is some process that's running on the network. So this is the same type of 3-tier architecture diagram that we showed in the last few lectures. And AWS is an infrastructure tool. In fact, is the largest, I believe, by market share that provides this infrastructure for very large-scale applications, right? So AWS is responsible for setting up and maintaining and managing these servers, and a lot of different companies rely on AWS's infrastructure to work correctly. In particular, Amazon has this DynamoDB service, which is kind of their database platform. They have multiple, but this is one of their database platforms that powers a lot of apps. And so the data server here the database that we're talking about might be one of these AWS DynamoDB databases. And then there's also EC2, which is another AWS tool, which helps run API and server functionality. So you can kind of see in our diagram here, this is where these two services correspond to, in our data server section and our backend server section. Okay? So even though we're using different tools in this class, right? We're using a Supabase and Postgres database instead of DynamoDB, and we're using Vercel to host our functionality rather than like EC2 or something like that, it is still analogous. So the diagram still applies here. And so remember from our last few lectures that all databases, right, are accessible on the network. That allows us to be able to communicate and perform operations on our database. In particular, right, all databases have some sort of URL. So with AWS might have some sort of host name like this, where it's like DynamoDB, and then dot is like some region. So in this case, US East 1 is the East Coast, AWS.com. That's kind of the host of where the database is located. You might have some larger URL, right, that this host is a part of, but this is part of that URL. And that allows us to access this database on the network. And remember also that as we talked about all the way back from lecture 1, all the way at the beginning of the semester, right, all of these host names or domain names, whether it be apple.com, google.com, right, the comp426 website, or in this case, this Amazon AWS.com, right, these are all these domains, but they actually are referring to some IP address, some physical address for a server somewhere. And that is how we communicate across the network and across the web. Right? So if one computer wants to communicate with another, it'll make a request based on the IP address. And so if you want to rack your mind and try to remember this, does anyone remember from lecture 1 what is responsible for converting this host name to an IP address? Anyone remember? Volunteer? Yeah. DNS, exactly. So stands for, right, domain name system. This is what we talked about all the way at the beginning. We haven't actually really visited it again since lecture 1. So yeah, DNS. That is what is responsible for taking some sort of URL like this DynamoDB, East Amazon AWS.com website, and actually converting it into some IP address on the network. And it turns out that Amazon maintains their own internal DNS system for converting these DynamoDB URLs into actual IP addresses, so that all of the server functionality for all these apps, like, for example, Duolingo or Canvas, et cetera, can find the database and then perform operations on it, just like how we've been talking about. And what actually happened here and what went wrong is that this DNS system is what broke yesterday. And so what that meant is that for these host names, like something like this, right, that we kind of talked about here, this host name, it was not actually getting converted to the correct IP address. So when these servers were trying to access the database didn't get deleted. It was still there somewhere on the network, but these servers could not find the database. And so, for example, in Canvas, if you're trying to load announcements or load your homepage, it would try to look in the database for that information, except that it could not find the database anywhere because the IP address was invalid. That the internal DNS system was actually kind of returning. And so ultimately, we severed the connection here between the data server and the backend server. And so all of the apps ended up breaking because they were not able to communicate with the database. And you can actually go here to the link. And this link, if you kind of read maybe on the news, You may have seen some links to this. This is the official AWS kind of website for information about this issue. This is very dense and hard to read, but I will kind of point to where this information is so that if you're ever, in the future, you might be able to make some connections here, right? If you scroll down here, you can kind of see, whoops, right? This particular node I believe this started at 2 a.m. Pacific time, right? You can see that we have identified a potential root cause for these errors. The issue appears to be related to DNS resolution of the DynamoDB endpoint. All that resolution is talking about, resolution is just taking the host name and turning it into an IP address. So you can see here that just that one small thing that went wrong ended up causing a significant amount of issues. We rely oftentimes on these systems when we're building these applications, but there are people in the back, in this case AWS, that's actually managing all of this infrastructure. And when it breaks, then major outages can happen. And in fact, this was kind of only scoped to the East Coast servers. So in the US East section, West Coast was fine, but it still caused a lot of issues overall. And ultimately then what ended up happening with this is that once they resolved this DNS issue, that caused more issues as you're developing, this happens. And so it took a while for the AWS engineers to fix all of these loose ends and for the fix to kind of propagate throughout all the apps. That's why Canvas only came, I believe, back online last night, a few minutes before I sent that announcement. I was checking that page periodically to see if it would ever come back up. Right? So hopefully this is kind of this might be interesting to you as it kind of relates to what we're talking about pretty well. And hopefully through learning some of these things as we have in this class, you'll be able to pick up on when something like this happens. You might be able to figure out what it actually means in context. Any questions here? Yeah. Oh, wait, sorry, one. Yeah. And then. Mm-hmm.
It wasn't like actually parts of the server that people were using specifically, but like, maybe I'm misunderstanding exactly. Mm-hmm. Like, how were they able to fix like some of the more like priority mm-hmm. things over others? Like United obviously got their stuff back.
Yes.
Like, how are they able to prioritize that if it's like a greater issue behind everything, not just like particular companies?
It's a good question. It's very possible, and I haven't looked into that case in particular. I think it's very possible that the initial fix went through and they were able to fix it, and then these larger servers that run these so these EC2 instances for these certain companies like United or Delta, whatever, they may have had to have some manual either restart, or they may have had to do some fixes for these really, really large servers in order to get those working. So because this is kind of, there were multiple issues that happened kind of in succession. The DNS issue started it, and then once they fixed it, they had to go through and manually do a lot of changes to make sure everything was working. Yeah, good question. And then, yeah.
Just like, did they ever release like what caused the issue in the first place?
So I have not checked. That was the main issue that happened. And I believe there may have been some more information that was posted, for example, last night. I think you can see that they had maybe some investigation. I'm sure there'll be more investigation as to what actually broke the DNS system. And that'll be what the engineers will have to work on and hopefully then fix so that it does not happen again. Other questions? Yeah. Mm-hmm. Yes. Mm-hmm.
How do you prevent this?
Yeah, it's a very challenging thing because a lot of that mitigation has to come from the provider. So whether that is AWS or if you're using Azure, which is Microsoft, or one of the others, they're often the ones who have to do it. You could, if you wanted to, and you have the resources as a company, could try and scale to multiple different providers and kind of have things running in different places so that if one goes down, you can use some other instance and using a different provider. The only problem with that, again, is like the database. You'd want to make sure, and this gets into more more advanced things with distributed systems and databases, but databases themselves, right? In order to have all the data, you could like duplicate the data in the databases in different places so that if one went offline, you'd have access to it. But again, keeping all of that kind of in sync is something that is a bit of a challenge. So that's why even large companies like Netflix and Venmo and even Vercel, everything went down and they all had to figure out and basically wait for AWS to fix it, right? So it is a little bit of a scary thought that a lot of these things that run our world today are often only relying on kind of these very few number of providers. And so if something does go wrong, for example, I believe I think Cloudflare, there was an issue a few years ago, and there's been issues that have caused, major disruptions. And so it's something that the engineers at these places have to kind of always keep on their toes to try and prevent. Yep. Any other questions? Great. All right. So I think this is a bit of it's an interesting aside. And I think there are a lot of cases like this. Oftentimes DNS is coincidentally a cause for issues, but there are others as well. And so if you ever hear about something like this in the future, I highly recommend looking into it and seeing maybe what might be going wrong. You can even ask if there's online, there might be resources. You can even ask, you can like paste this changelog into AI and ask, because it's a good learning experience. You get to learn a little bit about how these systems are actually working under the hood when something like this goes wrong, and you can get a good explanation. All right. So now we're going to get started with the content for today, and we're going to be expanding what we have been working on with kind of this backend and databases. Right, so we have talked about storing data in a database, and you have worked with A06 with actually interacting with the database using an ORM. Right, so database is just a structured collection of data, storing information that we've talked about in tables, columns, and we can have relationships that connect tables together. That you also have seen now in the reading, like for example, with states to cities, I believe, but California, for example, to Californian cities, that's a relationship between these two pieces of data. You'll also see that a lot in Oriole because, again, we have multiple database tables that are potentially related to each other. And then again, as we kind of recapped already in our aside on the AWS issue, right? These database instances are managed by some data server, right? So databases are like a running process that's running on a server, and that you can access somewhere on the network. So again, last time we saw something like this, where we have kind of our client side, we have our backend here, and then we have our data server. And all of these pieces are communicating in order to power the functionality for our applications, right? So for example, we said that if, for example, we want to make some database change, our client would make a request to the server. The server would then interact with the database using the ORM. So kind of like this way here, and then the ORM through Drizzle will interact with the database, and then finally we get some result back. And we use APIs, as we talked about last time, and as you'll see in the assignment, to manage this data flow. Right? In particular, we also talked a little bit about this idea of BaaS providers, or backend as a service. And all this means is it's just some sort of company or some provider, right, that manages the data server for you. And so a lot of companies, instead of kind of managing their own server and spinning up a database on it, they will rely on some other service to do it for them. This often leads to faster development, meaning because if you're like a solo developer or a small team, you don't have to worry about all the infrastructure, managing it, downtime, errors, et cetera. You can just let some other service do it for you. And it's also more reliable because there are people at these companies and who manage these services who are actually like their main job, their full job is to make sure that these databases are running, right? So it's not something that you have to really worry about, and it often makes your app more reliable. Unless, of course, some crazy thing happens with it, like the AWS issue, right? And so Not only do these providers oftentimes help us manage just databases, they also can help us manage other things and other features that are very important in our applications. For example, authentication, which we're going to be talking about today, file storage, also something we're going to be talking about today, real-time updating, and more. All of this we'll see as we kind of go through this module. We introduced at the end Supabase, which is the provider we are going to use. So Supabase is responsible for kind of keeping our database, and so we can then use Supabase to access our data. Supabase is great. It's extremely reliable. It has many of the same features as a very popular other services like Firebase or AWS. It integrates very well as well across different tech stacks. So whether you are working in your TypeScript web app, or maybe you want to make a mobile app too that uses the same data, there are all of these tools in all these languages that make this very easy to access your data. There's a very generous free tier as well, which helps for this class. There's unlimited reads and writes. The only limit that you have is on, I believe, like actual storage, but you will not hit that reasonably unless your app grows really, really large. Another good thing about this is that because Supabase is open source, if we ever decided that we do not want Supabase to manage this stuff, we want to actually run our own server, it's very easy to just essentially replicate what Supabase is doing, but instead of using their server, we can use our own. So it makes it easy. If we don't want to pay them later down the road, we want to just run it ourselves, we have that ability to do so. So vendor lock-in here is not a problem. Any questions with any of this, with the kind of our Supabase review from last time? Great. All right. So another issue here. So we've learned about storing data in a database, right? Except there's often many, many cases that I'm sure you can think about where we may want specific pieces of data to be locked or protected, right? So that only specific users are able to actually access that data. For example, in Instagram, right? If we want to make a new post, ideally, only the user should be able to make a post for themselves, right? I shouldn't be able to go and make a post for any of you or vice versa. Maybe if you're thinking about a bank, right? You wouldn't want just anybody to be able to access your balance. Only you should be able to access your balance. And so it's important to be able to essentially identify a user and to verify that that user is actually who we say that they are. And so that's the entire point of authentication. Right? So there we go. We enable this behavior with some sort of authentication system. When we talk about this terminology of authentication, all we're really saying here, right, in very simple terms of what you're used to with many apps, authentication is just this idea that users are able to log in to your account, create a new account, and sign out, etc. Right? That verifies that that is their own, I guess, that is themselves. Right? So when you're logged in, the idea is that users should be able to manipulate data that pertains to them. However, when they're logged out, then they should not have any access to that data. So whether that is writing data or also, for example, accessing in any form, so reading data as well. Right? Now, when users log in, they often have to provide, right, some sort of username and password. That is kind of the standard login method that we have had for a very long time. However, there are even more ways that users can authenticate. I'm sure you all have seen, right, the Google sign-in button where you can just press sign in with Google and it links your Google account and there you go, you're signed in. Also, if you use any of the kind of UNC-related websites, Connect Carolina, CSXL, etc., you will use this UNC Onion sign-in, where it'll redirect you, it'll ask you to sign in with UNC, and then it will bring you back to the app, and then you are signed in at that point. Okay? So all of that setup is there. And typically, we call these methods of authentication, we often call these authentication providers. So Google could be a provider, right, where Google is providing us a way to authenticate with our apps. UNC could be one as well, etc. And standard email and password also works very well, and then you don't have to worry about connecting with any external system. Any questions so far? All right. So now the question is, how does authentication actually work? There are two main opposing methods or types of ways that we can implement authentication in our apps. We have this idea of session-based authentication, and then we also have this idea of token-based authentication. We're going to kind of talk about what each of these are at a very high level, and then we'll go through kind of some examples to explain how this works under the hood. Right? So the first one, again, is this session-based authentication. And with session-based authentication, what we're saying is that whenever a user logs in, we are going to create a new session for that user and save it to the database. So the session is just referring to saying that kind of the time period that a user is logged in, right? For example, when you say like a gaming session, right? It's when you're ever sitting playing a game. It's kind of the same idea. Session is just a period of time you're using something. And so the idea here is that you essentially have your database keep track of a table. So you have a table. Whoops, I'm running out of space here. There we go. You have a table that's called like maybe sessions. And then every time a new user will sign in, you create a new row for a session. And it has some sort of ID. So I'll just say ID. And maybe this is just me, my name, saying that I am the one who is signed in there. And so the idea then is that this unique ID is going to reflect me being signed in with this app. And then I'm going to take this ID, and this ID will be given to kind of the client's browser. And it will be stored in this place called cookies. So you've probably heard of cookies, but cookies is just kind of this data store. It's a key value store in your browser that is associated with a specific website. Okay, so we're just taking this ID and we're storing it in our browser for later use. And then what happens is every time that the user performs some action, the request that is made to the server will contain this cookie. So it will contain this session ID, and the database and the server that you have developed is just going to check to see, does this session, is it valid? Does it still exist in the database? So to go to the database, check if there is a session with that ID, make sure that it is still valid, and then it will let you proceed and maybe give you some sort of data, et cetera. Okay. Now, the main problem with this particular approach, and the reason why, so in this class, what we will be implementing is not using this type of approach. The main problems here, is that the database has to store a table for sessions, right? So every single time that we want to perform any operation that we want to essentially keep as protected, where maybe only a specific user is supposed to access it, for example, checking your bank balance, every single time our backend is going to have to check the database to see, does a session exist? If it exists, allows it to proceed. If not, we're going to throw an error and say you're not allowed to do that. Right? And so that can lead, if you're having thousands of users at once that are trying to perform all these operations, and every single time you need to check the database to see if the session is valid or not, that can lead to some sort of issues down the road, latency issues, right? Because you're having to essentially perform these read operations on the database every single time to see if a user is successfully logged in. This is also particularly a problem with kind of distributed databases, something that we haven't talked about, but there are many issues that can arise from this particular approach. It's not bad at all, and a lot of apps use it, but these are kind of the problems that we face with it. So this is kind of a very high-level overview because we're not going to be using this method. The main thing to note here is that with session-based authentication, there's a database table keeping track of who's logged in at any given time. And every single time we want to perform some sort of operation on our database, we will check to see if that session is still valid. Are there any questions so far here? Yeah. Sorry, do you mind repeat? Yeah. Good question. So actually, we do. So let me actually think that because there is not a diagram for this one, I'm going to draw it out. I think that'll be helpful. So you can imagine that we have kind of the client side, the backend server, and then our database. So this is our database here. This is like our Vercel next backend. And then this is our client side. Okay. So what happens when we first sign in to this type of app, we're using session-based auth. We will make some sort of sign-in request. So there'll be some sort of request to sign in. So I'll kind of mark that here. Whoops. Right. So sign in. And then what's going to happen is in our next backend, we're going to create a new session row. So we're going to add a new session. Add a new session to a session table. Like so. So somewhere in our database, there is a table. So in here, there's a table called sessions. Like that. And I apologize for the handwriting here. This pen is acting a little bit, there's a bit of a lag on it. So I apologize. And so here, whenever we create a new session, whenever we're signing in, we'll add a new row to this table. So we'll add a row. Let's just give this session ID 1, and we'll say that the user is me. All right, so I've signed in with myself. Maybe somewhere in this check, I need to make sure that the email and password is valid, etc. And then finally, this ID here, this session ID, will be stored in the client side's cookies. So we will get some sort of result all the way back that in the cookies will kind of store this, we'll store this session ID of 1. So that's the first step. This is just signing in. So the entire point of signing in is we're just creating a session saying that this user is now signed in, and we're going to give that session ID to the client so that we're basically saying that this is the current login that you are, this is the current session that you're in. Then from here, let's say, so this is step 1. Does this make sense? Perfect. So this is kind of, I think a diagram here would have been helpful. So again, idea, so when we first sign in, we just get this particular session ID, and it's stored in our browser. And then after that, so I'm going to kind of erase these arrows so that I can show the next step so that there's space. So we'll just, whoops, there we go. Erase all of these things. As well as I can. These are very small. Okay, there we go. This is good enough. So that is step 1, signing in. Now the second step is, let's say I want to perform some operation to say, see my bank account balance, right? So I'm going to make a request for that. So I'm asking now maybe some API request. So we're saying get balance. So API balance. And along with this request, I'm going to pass along my session ID. So this particular session ID that's stored in my browser, this 1, is going to be passed along with this particular request here. And so then what's going to happen is the server here needs to see that, okay, in order for this particular person to access this balance, are they logged in? Are they who we say that they are? So then the server will need to do a check and query the database. This is the piece that is the expensive part, where every single time we need to check with the database, we're going to ask the database, is there a session with the ID 1? And is that person who we say they are? So maybe along with this, I'm saying that I want to check the balance for Ajay's account. And I'm checking the session. It says that I'm signed in right now, and I'm signed in as Ajay. Once we confirm that this particular thing is true and that a session is existing, we will then go ahead and actually check the balance, get the balance back. So maybe this is check balance. We get some value back, right? Let's say that I only have $2 to my name. And that $2 will then eventually make it back to the client side for some, maybe for some UI or something. Okay. So again, the idea here is just that we have to do, and this is the key thing with this session-based approach, and what is kind of, what is mentioned here, is that we need to perform this particular check, right? So you can see here that every single time a user logs in, we change this table, and also every single request we have to check the session table to see if the user is successfully logged in. So that requires us going to the database, asking for the data, coming back, right? And all this over the network, so it takes some time to do. Does that make sense? All right. Any questions on this particular approach here? Yeah. There are some benefits of having the session-based approach that are not really mentioned here. One of which is you can store, because you have a database table that stores the session, you can store more information about the session. So if you want more specific things about maybe data for while that user is logged in, or you want to keep track of when a user like signs in and signs out, right? All of that is available in a database table. So it makes it very nice to check. If we didn't have a database table, then it would be we wouldn't be able to store this extra data. And so there's some apps where that is more important than, for example, the latency issues that you might get. And so then they would use a session-based approach. Yeah, great question. Any other questions here? All right, perfect. So again, the key thing here that you just want to make sure is, and when you see the other example, I think, or the other type of authentication, you'll be able to compare the fact that we don't ever have to actually ask the database every single time for some sort of check to make sure that the user is signed in. All right, that's really the only issue here. All right. Everyone okay if I clear this particular diagram? Great, okay. So the other type of authentication, which is actually the one that we will be using in this class, the one that Supabase uses, and also other sites like the CSXL, for example, if you all either worked on that or have used it, these all use JWT-based authentication. The idea here is that instead of using sessions, which are stored in a database to keep track of whether a user is signed in or not, we are instead going to implement auth using what are called JWT tokens. Or this is kind of this in itself, JWT stands for JSON Web Tokens. And so maybe just saying JWT is fine, because otherwise you might be saying JSON Web Tokens. But this is, it's said in different ways, right? But JWT is essentially the acronym that we use to describe these things called tokens. And all tokens are, in this case JWTs, they are a secure way of sharing information kind of between clients and server using some sort of JSON format, which we'll see in a little bit. JWT tokens, or these particular tokens, are made up of 3 parts. There are 3 parts in this token. One is a header. All the header is saying is just describing what type of token it is and what maybe more information on that part after, but what kind of different algorithm maybe this token was using. We'll talk about that in a bit. And then there's a payload section, the actual data that is stored in the token. This might be information about the user, for example. So if I'm signing in as myself, maybe my token will say that this is the information about the user that's currently signed in. So that would be put here in the payload. And then the most important part here is that there's a signature that is also part of this token. The signature verifies that the token has essentially not been forged by anybody else. So the signature is signed by the server when a user signs in, which is just verifying. It's saying that I, the server, know that, for example, any user signed in. And when they come back to make another request, I can look at the signature and say, if I signed it, that means that they're good to go. I already checked them. They're good. If not, then they either maybe forged the signature or it was an invalid login and they would be denied access, right? You can kind of think of this, and we'll have a in-person example here in a moment where you can kind of see this actually work with kind of some role play. But you essentially are the person, if the server is just maybe giving like free access passes, and then whenever a person comes back with access pass, you just look at it and say, did I sign this? If so, then you're good to go. And that's kind of the idea here of these tokens. And so the main difference, and as you'll see in a moment of how this works, is that with this type of authentication, the server never ends up storing kind of data about sessions. There is no database table that we have to query. Everything is done using just this token, which we'll see here in a moment. But ultimately, this just makes this type of authentication more scalable. It also reduces kind of the load on databases. You don't have thousands of database requests that are dedicated to just checking session data. So this one, conveniently, I do have a diagram for, so this might be a little bit more helpful. So you can see here I have my client side. I've added a little section for my cookies there, so it's easier to see. And then on the right-hand side, I have my server, my data server here that is, and actually, I believe the way that this diagram is laid out is I kind of condense these things. You can ignore the fact that there's a database here because the database we're not actually going to be talking to, okay? But we have some sort of server code. So what happens is that our client will make some sort of authentication request to the server. So this could either be our server, it could be Supabase server, which is why here we have data server written. So we make some sort of, and whenever we say authentication request, this is just me saying that I like click a sign in button or a sign up button. That's all I'm trying to just authenticate myself. And what will happen is the server here will generate a token that is based off of me as the user. Right? This token is cryptographically, it's signed by the server code. So what this is saying is the server is verifying that I see that you're trying to sign in, right? I know that you're, for example, maybe I checked your email password, you're good to go. I will sign off on the fact that you have authenticated, and I'll take that signature, I'll put it in the token, and then this token is then going to be placed in the cookies in the user's browser. So you can see this particular flow here. And then our cookie is placed in this in the client, right? So this cookie, remember, contains a signature. The signature is the signature created by the server that's just verifying, saying that this is this user. I am verifying that this user is good. They're authenticated. I'm signing it. I'm signing them off. Okay. And then what happens, just like kind of before, whenever then we make some sort of request to the server, let's say to check for some bank information, something like that, or a balance, we will just take this particular token and send it back to the server. So this is the same token that the server signed for us. We're just going to give it back to the server. And the server can then check and see, did I, the server, actually sign this token, right? If I did, it means that this person is correctly authenticated. If I did not sign it, then it means that this person either forged some sort of token or is trying to gain unauthorized access, and so we will not give them the data they request. All right, so if the token is authentic and it's good, it was made by the server, we continue on with our request. Otherwise, an error is shown like so. Questions so far? All right. I'm going to show now, as part of this particular arrangement, this diagram, how this signing actually works. So you can follow along at a high level. I know that people have different levels of maybe experience based on classes they've taken in security. So there's no, if you haven't taken any class like that, don't worry about it. I'm trying to do as simple as possible. I'll also note that these details are not something that you need to stress about for the midterm. I wrote it as well at the end, but I think it's important to talk about because this class is one of those that really relates to all of the different classes that you could take in the major. And this is just another example of a class of courses that 426 is related to. Okay, so let's get started with this kind of here. So again, we said a JWT is made up of 3 parts, right? You have the header, you have the payload, and then you have the signature. These are our 3 parts in this token. Right? The first thing here is the server will assign some sort of payload. So this is actual data that's stored inside of this token. This could be, for example, a user ID or a username or some information about the user, so that it's stored, and whenever we get this token back, we know that this is the user who's making the request. So it's good to have this information here. Okay. And then after this, the signature or the server will produce some sort of signature for this token to verify that the server checked off and knows that this person is legitimate, and that after the fact, we can just look at the signature to determine whether or not this user is authentic. And so how the signature actually goes about, or how the server actually goes about producing this particular signature, is there's some algorithm. So if you've taken a cryptography class, you may have heard of this, or if you've taken some other class, right? There is this idea of this message authentication code algorithm. There's various different ways of doing this, but the kind of idea here is that we have some sort of function, and we pass in a message or the payload into this function, and out will produce a signature. Okay? Now the difference here is that in order to make sure that this signature is essentially unique to the server, so only this server can produce this particular signature, that way no one else can forge it, this particular algorithm or this particular function also takes in some sort of secret key. So this key is usually some 256-bit string, and it is used to create new signatures based on any input message. Right, so the idea is that every server that is running authentication, right, every server will have some different secret key associated with the server, which means that then they all have some unique function where when you pass in the message, you'll get a signature out. And so that way, if I, for example, am trying to sign in on Google, I sign in successfully, but then I take my token and try to give it to apple.com, it's not going to work because they have different functions with a different secret key, right? So that's kind of the idea there as to why this is unique to different applications. The final token will then contain both the message, which is the payload, and the signature all attached in there. So what this might look like, something like this, right? Our very generic token has a payload and a signature, but in a more concrete terminology, you might have something like this, where you have payload, you have my user, this is user Ajay, and then we also have a signature. And the signature was created based off of this payload using this particular cryptographic tool. All right? Questions so far with this? Yeah.
Keyword, like, is the key passed in, or does both parties know about the key? Like,
good question. Yeah, so the key is only known by the server. The reason why is because if this particular key, it needs to be secret. If this key was public, then anybody could create signatures, like anyone could forge signatures that would make our authentication invalid, right? So if we have like a server here, which is doing our authentication, and let's say we have some other device here, and then we have some malicious user. If the key here is also shared by like some malicious user, this malicious user could create the exact same signature and essentially pretend to be the server, right? So because these keys are the same, the function ultimately here, in this case hmac-k, that is the same. And so for the same M, we would get the same signature, and therefore somebody could get themselves into our app and have access to our data. Is that kind of, okay, perfect. Yep. So yeah, the key is secret, very important here. All right. And so again, the idea of this, we already kind of talked about this step, just showing it again. This is what's happening in this particular like loop arrow here, right? So we are taking our secret key that we have, we're taking some sort of payload, which is the user who's trying to authenticate, and we're running this all through this function, and we get some signature back, and all of these pieces are combined into this token and placed here. The idea then is that you can see here the token contains our message and our signature. And then on subsequent requests, for example, I'm trying to get some sort of bank data again, I will pass this token back to the server. And now the server has to verify that is the person who's making this request actually authenticated. And the way that they'll do that is it'll just take the incoming token, which contains both the payload and the signature, right? So in this case, I've kind of marked this here as M prime and S prime to denote that these are like the new token that's coming in. There's a message and a signature in this token that we can see. If we run this particular function again on this new message that is incoming, and it computes to the signature that also is incoming, right? Then we know that the server was the one that signed the token. We know that because, again, this particular function right here with this HMAC-K and this secret key, right, is only known to the server. So the only way that if we take the same message and we get the same signature out, right, if all these things match, then we know that the user was authenticated using our server's algorithm to do so. The entire idea here behind this is that we can use math, essentially, to verify whether a user is signed in. We don't need to query a database, and we don't need to worry about managing sessions. All right. Any questions here so far? Yeah.
For every user, or is it same signature for everyone?
Good question. It is unique for every user. The reason why is because usually the user data is passed in as M. So the signature that we get out will be unique. Yep, very good question. All right. I know that that's a lot. I know no one expected math or cryptography in this class, but this is ultimately what is powering all of the security and the authentication behind the applications that you use every day. And so again, this is our same diagram that we had before. And so I think to make this a little bit more concrete, we're going to have an in-class demonstration, and I'm going to cold call my two of my TAs down here for an in-class demonstration. So let's see, who is here? I see Charlotte, want to come down, and I also see Jade at the corner, he can come down. All right? So we're going to kind of do a bit of a role play here to demonstrate how this actually works, because I think that this might be helpful. So unfortunately, I wasn't able to unlock this box, but you can imagine that this box is some sort of database that I am standing in front of, right? I'm the server, I'm trying to protect this database, and I have two users here who are going to be trying to authenticate. All right, so I'll have both of you all stand over here. You are my users, and you can kind of see that this will match up with the diagram, where I have my users, my clients on the left-hand side, and then I have me, the server, on my right-hand side. All right, so let's say that I have, and I don't really have, again, this box is not opening. So let's say that I have some very important, let's use, I don't know, let's use this particular box here. Let's imagine that this is some very valuable gold bar or something that someone wants to get, or maybe some sort of data about maybe the balance that a user has, right? So let's say that Charlotte is trying to access her bank account balance, right? So she'll come over here, and she's going to ask for it, right? And so we can assume right now that she is completely unauthenticated with the server. So I will say, I'm sorry, you are not authenticated, right? You cannot get your information, right? So now, let's say you go back, and you try and now sign in. So let's say you're going to sign in. So you come over here, right? And I'll say that, all right, this is Charlotte. I can verify. I see that that is her. So I will create some sort of token. And in the payload, I might write user equals, right, Charlotte, like so. So you can see now in the payload, I've written that this is the user that I have, just Charlotte. And then here in the signature, I can now say that, well, I want to sign off of the fact that she has signed in. And so I'm not going to use the cryptography here. I'm just going to write some sort of signature down, which verifies I signed that Charlotte is authenticated now with the server. right? So I give her this particular token, and she can now go back, and she's now signed in, right? So that is step one. Now she wants to access her data, so she'll come back, and I will then look at this token, right? She brings the token along with her. I look at it, right? I say, yep, this is my signature. I verify that she is allowed to access this, and so I'll now hand it to her, right? You can take this back, and there you go. That is how this works. We're just looking at the token to make sure that I signed it, and if I signed it, then I can give her the data that she wants. All right, I'm going to have this box here. There we go. And so now, in the second example, what I would like to do is imagine that I have Jade, who is a malicious user. She wants to access Charlotte's information, even though she is not Charlotte, right? So what she's going to try to do is she's going to try and forge a token to pretend that she is Charlotte, right? So in the payload section, you can also look at it for some information. You might be able to, she'll try and write down her user as herself, and then she's going to try to forge my signature as well, right? So she'll write some information down, like so. And then she's going to try and forge my signature in some way. There we go. So now she is going to come over and try and access Charlotte's data, right? I look at this, and I see, OK, payload's fine. This signature is not signed by me, right? It's visually, it's just, this is not my handwriting, not something I would sign. So say, I'm sorry, you're not allowed to access it, and you must go back, right? So this type of authentication, and with these tokens, is what powers a lot of the applications that we use, including the CSXL website and also the websites that you will be using. Big round of applause to the TAs for this demonstration. Thank you. All right, so that is all. They did not know that they were going to be called on beforehand, so I appreciate their improv skills. Very well appreciated. And for those TAs who are not called on today, maybe one day we'll get to you by the end of the semester, all right? So does anyone have any questions about this idea of tokens and assigning? I think that the visual, just understanding at a more basic level, ignoring kind of the math behind it and the cryptography behind it, just this idea of using the signature and verifying it, maybe even in the physical world like we did, might help a little bit ground this a little bit more in reality. All right? Perfect. Any questions? Amazing. All right. So the key thing is, and you can imagine, as we've been talking about this, and there is a decent amount of the cryptography functions behind this as well, is that implementing all of this logic manually is difficult. You can do it. The CSXL site, for example, does do this manually, and there you can totally build your own authentication, works perfectly fine. However, if you don't do it correctly, right, your app can be vulnerable to attack, right? For example, if I am not verifying the signatures correctly, then anybody could access my data, and that would be very, very bad. And so you can also use different providers to manage authentication for you. There are, of course, you don't have to. There's different ways of doing it. In this particular class, we will use Supabase to also help manage authentication. And so Supabase has a service called Supabase Auth, which makes it very easy. So Supabase Auth is responsible for signing tokens, and then you can verify that the token is legitimate on the server side. So you can use the Supabase functions to essentially handle the hard parts for you. Right, so again, by default, right, Supabase does sign these JWT tokens. And if we go to Supabase's website, you will see that under like product authentication, there is some detail somewhere in here, it's documentation, talking about, right, how authentication is managed. You can see here, right, Supabase Auth uses JWTs for authentication. It talks about kind of what we're discussing, and then it also has many different providers that you can use as well. So if you want to implement Google Sign-In or Apple Sign-In or GitHub Sign-In, you can do that using Supabase. All right. And so Let's see here. What's next? What I would like you to do real quick is there's this link here that I have. Hopefully it's still working. So I was actually trying to deploy this example yesterday, and that's why I learned that Vercel was also affected by the AWS outage. So, and Supabase was as well. So I'm hoping that this example is working because it was rough getting this online yesterday. So we'll click on this website, and you should see some sort of website like this. This is a very basic Supabase auth example. The code is public on the class GitHub, so you can see how this works, where I have a login button, and then I have a create account and authenticate button. So I can either log in if I already have an existing account, or I can create an account myself. And so I will do that to show this off. So I'm going to type in, for example here, j@gmail.com. And then for a password, I will type in some sort of password. And then I will just press on create account. So I'd like you to follow along, create some account with an email and a password. You can use any that you want. And when you press the sign up button, I'll just say not now, you should see that there's a link here that says that I am authenticated. Now, one thing that I want to highlight, so whether you're in Chrome or Safari, you can do this. I happen to be in Safari. So you can go into your DevTools, and typically there's a section called storage or something related to it. If anyone is in Chrome, you can verify for me or tell me if it's not there, but you should have something typically for storage. And you'll notice that you have a cookies section for storage here on the left-hand side. So if you're in Chrome, and I can open this in Chrome as well to show, but you should have a section for cookies. And what you'll notice is that you'll actually have, I have two because I did an example before. There should be a cookie in here that has some name associated with it, but then it also says auth token at the end. Right? So this is the token that Supabase put in my cookies after I signed in. Okay? Now, what I want you to do here, and I apologize for the mic issues, is you'll notice that there's a value section. So in value, you can actually copy this value. Everything after this base 64 dash, you can copy, and this is the actual token. You'll notice that it doesn't look like it's in JSON format because we still have to decode it, but we can take it, and there's this great website called JWT.io that I've linked, which actually shows us what a token looks like. So if I go in here and I click on this, I can paste in a token. And you can see here it gives me an example where you have a token here, and then it shows you kind of what the payload is, where this is the information about the user. If I paste in this value in here, you'll notice that the decoded data in this token includes, for example, my user, where it says that I'm authenticated, here's my email, here's when I last signed in. All of this information was provided in this token by Supabase. The actual signature is slightly harder to find, but it's also part of, it is part of this particular string as well. Typically, and I cannot find it here at the moment, and it might be in a slightly different format, but a lot of times these tokens have like a period that separates the payload and the signature. And so you can actually see what that signature looks like and determine whether or not from there it is valid, right? But this is just our way of decoding this particular token. And so you can see that all of the data about our, for example, auth provider being email, and all of our data about our sign-in is accessible within this token. And so this is very useful because as we are trying to perform requests and operations, we have this particular data about our user stored in this token. So I'd like you to do, and there should be a submission open on Gradescope, where you can paste a photo of this particular output that you have after signing in. I'm also going to open up Chrome real quick so that I can show you on there. Let's get this on. All right. And so I will go to the same URL. Oops, so we'll refresh here. Paste this in. Thank you. There we go. So this is Chrome. And I can log in now the same way just to show you. So I can log in. login. You can see I'm authenticated. And if I go to inspect, okay, I do see. So I believe, let's see, where is this here? I've not. Thank you. Application. So I apologize. It was not in storage. It might be called storage on Firefox, but at least in Chrome we have application, and then there's a section underneath it for storage. And in this storage section, there's cookies. And if you press on the cookies icon here, you should see the auth token available in the cookies. So just take a screenshot of either this page or the JWT decoding page, and then upload it to Gradescope. We'll spend 2-ish minutes on that, and then we'll finish up with the content for today. All right, great. So make sure that you work on submitting that. We do have 5 minutes. I want to finish one important thing for our assignments, since we ran a little bit over in our authentication talk. So again, the repo is linked here. You have until, so if you need to keep worrying about submitting, feel free. And then also, if you're interested, there are 3 courses that I would recommend: COM 435, Computer Security Concepts, 590, Privacy Enhancing Technologies with Saba, and also COM 537, Cryptography. All of these courses go at various, I've kind of ranked these in kind of maybe the depth of that they go. Cryptography will actually teach you the full-on math behind how those functions work, rather than maybe how, I mean, they will talk about application, but they really also talk about the math behind it. So if you're interested in this type of thing, it's a very big field. I highly recommend taking one of these classes to dive deeper. And again, I'll note, right, so for the midterm, things like actually signing and verifying, you do not need to know. Main thing, I would just focus on the difference between session-based and JWT-based authentication, all right? And so the last thing here I want to mention is that with Supabase, we can do many things. We can do databases, we can do authentication. Another thing that we haven't discussed yet is this idea of storing files, right? So for example, in a social media app, people are going to be posting images. And where do we put images? Right, so images are like these larger files. We can't just store them in a database. And so that is a problem that we need to figure out where we can store these files. And so there are many providers that allow us to do it. The main common one is AWS S3. This is the one that kind of is the most ubiquitous out of all of them. And most of the other storage providers follow the same S3 format. However, Supabase also provides a S3 compatible storage system, which allows us to essentially upload, download files and store all of those files kind of related to each other, which is really, really nice. It also provides good integration with its authentication service, which is also pretty good. And so how storage works is just like in our data server, we have a database. Our database is storing the tables, all of the data that we had before. We store files in what's known as object storage. So we have database, and then we have a second kind of category called object storage. And in the object storage, you have these things called buckets. And so you essentially store files in these buckets. You can have multiple buckets that store related files. So for example, you'll see in your assignment, you will have 2 buckets that you'll be working with. One is images for like user posting of images. And then you also have a bucket for avatars, so like people's profile images. And so we can create these different buckets to better organize the files that we're trying to store. Right? And ultimately, then we will ask Supabase. So Supabase has an API that we can use to actually go and access these particular files. And so you'll have the chance to work with these things as you begin to get started with Oriole, because in that assignment, you will, again, be able to post images and change your profile photo. And so you'll be working with a Supabase object storage and bucket along with that. Are there any questions about any of this particular stuff with object storage? Great. All right. So I know that this was a pretty packed lecture to get us started after break. So I do appreciate it. If you have any questions, please let me know or come to office hours, and we'll see you all on Thursday.